My fellow students and researchers, welcome back. This is video number 60. All right, in this video, we are going to address step number 5 in the structural model assessment. Okay, this is Q square. In the last step, number 4, we have addressed F squared, the effect size. Now we are addressing that predictive relevance. Okay, and this is the last step in the structural model assessment. It is a very important step as well. All right, let me just brief you about it. Okay, while in the effect size, we have tried to omit some exogenous variables in order to understand the variation or the variation in the effect between one exogenous variable and the other, or one independent variable and the other. In this step number 5, it is pretty similar actually. We understand the variation of the impact between one independent and another independent variable on the dependent variable. But in this step, we have to understand the omission of data. Okay, it's not simply the omission of variable, but it's simply a modification or an adjustment in the set of data that we have collected through our questionnaires. All right, let's now move into, as I usually brief you, start with a PowerPoint presentation with some slides to give you some theoretical, some educational background about what I explain, and then I move into showing case the application of the actual step or lesson or whatever we are into. Okay, let's share here a PowerPoint slide. So, okay, we go advanced and then share. Okay, let me share, and then video number 16 here. All right, here's me back with you. All right, okay, let me show you a bit larger. All right, okay, so in step 1, this is the last step, as I mentioned, in the structural model assessment. This is Q squared or the predictive relevance. Okay, it's different from the effect size or F squared. Okay, while the effect size, let me use some annotation here. While the effect size, I can't use annotation. All right, while the effect size addresses the variation between one variable and the other, so F squared deals with its contribution of each independent variable on the dependent or exogenous on the endogenous variables, depending on what key term you like to use. They're actually both synonyms: independent, exogenous, dependent, endogenous. Okay, so Q squared uses, as you notice here, the omitted data set to predict the relevance of a specific independent variable in respect to the dependent variable in our case. Okay, so here we have data omission. All right, we remove the whole data from our data set, not me, not you. Actually, SmartPLS does that, okay, through the blind folding procedures. Okay, we'll come to this function in a bit, all right? We'll come to this function in a little bit, all right? SmartPLS will actually use the blind folding procedure in order to calculate the data omission, all right? A specific distance. We'll come to this in a bit, all right? So Q-squared uses omitted data set to predict the relevance of a specific independent variable in respect to the dependent variable and based on the omitted data set. It is actually a good way, it is a very good way to look at whether or not that data set can actually work on its own data or multiple integer number of the omission distance using the blindfolding procedure, okay, can still have a strong predictive value on the dependent variable. Okay, so it is a process that will help you understand whether the omission of data, okay, the omission of data would actually remove or have a specific predictive value on the dependent variable or not. So the same as we did in the calculation of f squared, as you know, we have, as you remember, and you can go back also to this video number 15, we have included a variable, got r squared, then removed that variable and got r squared excluded. Okay, we had r squared included once we have all the variables included. Okay, and then we have r squared excluded when we remove that variable just to check the impact on r squared. Okay, and we end up calculating the f squared. All right, let's move further here. Okay, as a rule of thumb, we have the same pretty similar formula. Q squared is equal to Q squared included minus Q squared excluded divided by 1 minus Q squared included. Okay, omission distance is usually between, as a rule of thumb, 10 and 5. Okay, SmartPLS will give us an omission distance up to a maximum of 12. But as a rule of thumb, we go usually automatically, by default, it's set to 7. Okay, we'll keep it simple and we use it just as 7. All right. According to Hensler et al., 2009, if we had Q squared that is around 0.02, that's weak, moderate, above 0.15, that's moderate, and a strong one would be equal or beyond 0.35. All right. So this is a rule of thumb here. All right, let's move further here. Okay, an important note for you here. Okay, and let me just remove myself a bit, all right? An important note here. The number of cases in your data set must not be a multiple integer number of the omission distance, okay? And in case of so, the blindfolding procedure will be erroneous, will result in errors. All right. Further on this, let's see more. This slide, as we have noticed in the effect size, whenever we have higher t-value or the higher standard beta will result into a higher Q squared. Okay, okay, this should be Q squared right in here and not, all right, and not, let me escape this, okay, not f squared. All right, so I couldn't fix it actually, but you can fix it. This is Q squared and not f squared, okay? All right, let's do first, let's share, do now the calculations, all right? Let's move on and do the calculations and then wrap up with a conclusion before moving into further very informative, educational, instructive videos using SmartPLS as a part or the main focus of this video series. All right, let's move into SmartPLS right now. Share. Basic. All right, let me share with you SmartPLS window here. All right, now we're in SmartPLS. Okay, you see me, I'm right here with you. Let me see if I can make myself a bit bigger, all right? Okay, now you see me better, all right? Okay, now I'll use some annotation. I can use annotation now. All right, I usually love to use the tosh, maybe. All right, the tosh as an annotation. All right, what we'll do here, all right? Now, I have trust, perceived usefulness, perceived ease of use. They are pointing to attitudes towards using online banking system use. Okay, this is our model. We have started our video series with this same model. We're focusing on this same model using the same data. So I don't get confusing for you. All right, let's see now. What do I have to do now? All right, simple. Okay, so I don't need this. I know that this is pointing to this. I would need only to worry about the attitudes for now, okay? And not even behavioral intention to use. All right, how do I get Q squared or the cross-validated redundancy? All right, let's see now. Okay, I go into calculate, as you see that little touch is really beautiful, okay? Into calculate, all right, calculate, and then blindfolding, as you notice here, okay? Blindfolding, let me use the mouse, maybe I can move it, no, I can't. Let me go back with the touch. Blindfolding, okay? And then as you notice here, the omission distance, as I told you, by default, or as a rule of thumb, we have between 5 and 10. But the system, as you notice right here, the system gives it as, SmartPLS gives it as 7. All right, what can we do right here? Very simple. I want you actually to read. I want you to read this. Like SmartPLS is very informative software. Besides its functionality and ease of use and great value in quantitative data and structural equation modeling, it provides you a good educational or literature background. And it's usually good to read. Here, it says the systematic pattern of data point elimination prediction in the blind depends on the emission distance. The user must have a value, suggested value between 5 and 10, but as a rule of thumb, as per rule of thumb, it has to be between 5 and 10, okay? 7, for example, applies. Look what it means. An omission distance of 7 means that every 7th data point of the target construct indicators are eliminated. Okay, 7th data point is eliminated in a single blindfolding round. Since the blindfolding procedure has to omit and predict every data point of the indicators used in the measurement of a certain data, it comprises 7 blindfolding rounds. This is once you use blindfolding of 7. However, when you use blindfolding of 10, so you would have eliminated data every 10th data point, okay, etc. It's important to note that the omission distance has to be chosen so that the number of observations in the data set divided by the omission distance is not an integer. And as I mentioned, if your cases, we can go back maybe to the PowerPoint here, all right? Let me go back to the PowerPoint. I'll have to do a new share and then advanced and then the PowerPoint share here. All right, number 16. I'm back in the PowerPoint here, all right? I'm back in the PowerPoint sharing with you. Slide, this one, all right? The number of cases in your data set must not be multiple integer number, all right, of the omission distance. And in case this happens, we will end up with an erroneous blindfolding procedures in the results, okay? So this is important. Please make a note, all right? Write this down, make a note of this, and let's move back to SmartPLS here. Okay, how do I move back to SmartPLS? Share screen and then basic, go back to SmartPLS. I'm now in SmartPLS actually. All right, back to where I was. SmartPLS, okay, I explained this for you. Let's now run the calculations. I chose 7 here, and then start, all right? As you know, it's 1, 2, okay, 3, 4, 5, 6, 7. It was just a quick, I got a very fast computer, some processing. All right, so we have, because we use 7, okay, as a distance, omission distance, we have 7 cases in here. All right, if we go back to, this is the construct cross-validated redundancy. And if we go back to our model here, and this is the result that we have here, okay? So this is the CVR, it is 0.155, okay? So now, how do I report this? How do I do the calculations? Also very simple, very straightforward. Okay, let me now share with you now. All right, I'll share with you. I'll have to share with you actually now uh, the, the, the Excel sheet, all right? So new share, I will go with my Excel sheet, all right? Share. All right, you see here in video, this was relevant, this is for the effect, here, the effect size, all right? This is F squared, all right? Now, what I have to do, let me fix this up, put superscript here. All right, now I'll simply copy this. Oh, well, I did it here actually, okay? Okay, let me do it right here, okay? Simply copy this and then paste it here, all right? What I'll do here, remove all of these, and this is instead of R squared, this is Q squared, all right? And this one is also Q squared, excluded, and this is the effect size, this is the predictive relevance. Okay, very simple, very straightforward. Okay, I have the same variables, I scan simply, and this one is the predictive relevance, and this is instead of F squared, I have Q squared. I'll run the calculations, very simple. All right, let me underline this, I make it just look beautiful more. Bold this one. All right, we have trust, perceived usefulness, and Q included. What's Q included? This is the, let me share again. Do I have to share every time, or simply it should jump? New share, what am I sharing? Okay, let me share screen. I'd say if I share the screen, then it will move by itself instead of just sharing every program at a time. Share the screen, all right? I'm now sharing the screen. You are sharing, you are screen sharing. All right, new share. Okay, screen sharing, all right? I'm sharing the screen now. Now I can simply, if I'm sharing the screen, move back to the software, and I think you should be seeing that now. All right, we have 0.155. Then now I go back to the Excel sheet, all right? This is 0.15, okay, 0.155. And the same, all right? For all of them, the same. This is the Q squared included. Now, how about Q squared excluded? Very simple, as we did with the effect size. Now we go back to this one, and I start with the trust one. Just remove this, okay? Remove. Run again, okay? I can use the torch, maybe make it easier for you, just to see, okay? The torch is beautiful. I'd say the torch, spotlight, maybe this one, error? No, no, I'll use the torch. No, I don't like the arrow. Okay, so now calculate, okay, blindfolding, and then the same, run the calculation, quick, okay, 7 cases. All right, and then we go into the model, and it is instead not much of difference, however, it is 0.154. Okay, very simple. Go here and trust 0.154. Right, done, okay? Then go back. I have to undo. I undid, okay? Now I go into perceived usefulness, just delete this one and then run it again, blindfolding, start again, all right, and then go to the model, 0.110, that's a major difference here, okay, and then go back into the Excel, 0.110, all right, so 0.11. Fine, I can show if I want the 3 integers here, just the 0 didn't work. Anyways, I don't need to, it's the same. Undo again, okay, let me undo, all right, and then the construct is back to its place. And the last one, perceived usefulness, the last one is perceived ease of use, all right? Simply again, the blindfolding techniques and start, and then go back to my model and then 0.115. 0.115. Okay, so and then back to what I had. All right, so simply now I have this and I got my formula. My formula would be, I remember this formula, F squared, F, etc. So let me go back to my formula. Okay, my formula here is in the PowerPoint slides. Okay, in the PowerPoint slides, uh, let me see here. It is q squared included minus q squared excluded divided by 1 minus q squared included. Okay, so it is equal to open parentheses, all right? Open parent, oh my gosh. Now here. Open parentheses included minus excluded, close parentheses. Okay, close parentheses divided by open parentheses. Again, open. I have some sort of a keyboard. 1 minus included. Okay, the q squared included. Okay, and then close the parentheses. So it is. Let me go back to the PowerPoint here. So okay, 1 minus q squared included. Okay, and this is F30. That's right. FG. Okay, F30. Okay, and that's it. Okay, simply drag to apply the same. Okay, so this is the predictive relevance. This is q squared. Now I have this q squared. What I can simply do is simply copy into the main table, the relationship table, that the main hypothesis testing table, all right, or the direct relationships table. It's very simple and straightforward. So we take trust, all right, we take the trust q squared equals to this one down, and equals, this is perceived usefulness equals to perceived usefulness, this one, and equals to this one. All right, so what do I have now? All right, and as you notice, okay, as you notice here 0.1183 is done the same, almost the same. Maybe the trust is 0.154 and this is 0.00. This is trust, and the perceived, okay, this is equal to 1183, and this is, no, there is 5325. That's okay, beautiful. And the last one, the perceived ease of use, it seems I copied that wrong. Okay, so it simply equals to this one instead of the first. Okay, so 0.04, 0.05, 0.00, as I told you here. Okay, let me show you here. Higher t-value and higher standard beta will result in higher q squared. Let me see, is that true here? Okay, this is standard beta compared to this is lower. Okay, so that's why q squared is higher here, lower here a bit, and much lower here. Okay, and this applies actually. Okay, that's true. All right, so this is done with the predictive relevance calculations, and we reported the results here. Now I have my table ready. Okay, I can simply, for the sake of simplicity, I just use these three variables, but for sure we can study other variables if we need to. Okay, so here, okay, now what we have here, simply the table. Let me copy the whole table here, all right, and let me report it. Okay, now I am sharing screen with you, new share. I am sharing actually the screen, the whole screen. So simply if I go to PowerPoint here, Word doc, okay, reporting the results in the Word doc here. Okay, let me just take this away a bit. Okay, and let me just go back to the mouse. Okay, and now what would I report? Let me just make this as layout. Let me make it landscape instead of, okay, this section landscape. All right, okay, that's fine. And then copy the whole table right here, okay, and drag it a bit so it's a bit smaller. Let me fix this a bit. All right, okay, that's good. That looks better. That looks good for me. Okay, it looks good for me. And simply call it table, maybe table. This goes in chapter, in your thesis or dissertation, maybe goes in chapter 5, if you're using like a seven chapters thesis format, maybe a 0.7. Okay, and this is the direct relationships for hypotheses testing. We can call it like this, okay? And simply bold it. And all right, testing for direct relationships or hypotheses, direct relationships. And we have, I prepared for you some notes actually. Okay, here we see, let me maybe, I don't know if I can view this a bit larger, but you can, I think, okay. So simply what I do here, I get the value of R squared, I get the value of Q squared here. My Q squared was, okay, let me now take this away. I'd say take it here, put it here. Okay, and R squared was 0.198. Okay, we got that earlier. So this is R squared. Okay, it's simply, all right, what do I have to do here? Let me just remove this superscript and just, okay, R squared, all right. And F squared, I have to remove also the superscript, yeah. F squared is equal to, from the exercise, 0.155. No, sorry. This is R squared. Okay. No, that's not R squared, actually. That's F squared here. What was F squared? Okay. All right. Let me put Q squared just to make sure what we had as R squared excluded. This is the effect size actually, okay? So R squared, we had this, F squared, we had this, all right? We had this for each one. A Q squared 0.15. Here now, I would say, let me go back to this one. I'd say this is R squared. This is, okay, this is 0.198 is F squared, okay? And a Q squared is 0.155, all right? So let me remove this and 0.155. And for R squared, it's not actually 0.198. Let me get you R squared. R squared, simply we get it through the PLS algorithms, okay? And let me run the PLS algorithms, and this is R squared over right here. Okay, ask R, it is 0.198. All right, so it is 0.198 here. R squared is 0.198, so this is R squared. So cut this. All right. For F squared, we have to use those, the effect size, we have to use those. And in this case, Q squared included is this much, R squared included is this much. For the F squared here, it is the effect size, and we have to use one of those. But actually for this one, I have to just do further look on this just to make sure I'm getting you here the right answers, okay? But most probably, as you noticed, it is actually for each variable, it's separate, okay? So that's for F squared. All right, and now I got my results reported, okay? Where did I report those? Okay, I got my results reported, okay? And for here, for the F squared, I use Cohen 1988 as a supporting reference. And for the Q squared, the predictive relevance, I use the Hensler et al. 2009. Okay, so now this is for step number 5 in the structural model assessment. This is how we explain this, showcase this blindfolding procedures, and step number 5 in the structural model assessment, presenting it in this video number 16. Let's go to the last slide actually here. Let me share with you. Now I want to share the slides and go just to the last slide, all right? Okay, back to last slide, conclusion, all right? In conclusion here, as I explained for you, in this video number 16, I provided the Q-squared calculations, showed the case using SmartPLS for structural equation modeling. I explained what it means, how it is different from the effect size. All right, thank you for watching, and please always subscribe to this channel. Much more videos are coming. I'm planning just to cover everything around quantitative data analysis using SmartPLS in details. All right, in details, not leaving anything, using the most advanced technology to provide you with the best videos that will last with you. Please stay tuned. A new video number 17 is coming very soon. All right, thanks for watching. Dr. Ayub, you can leave comments below, any questions if you have, and in case you need any private help, maybe you can just WhatsApp me. All right, thank you for now, and we'll see you soon. Bye.